All right, so I had a student ask me an interesting question about domain, codomain, and range of inverse functions. And yeah, I just wanted to dive into it a bit more. So let's imagine we've got some function. It's got the domain 1, 4, 5, and 6. You can see what they're mapped onto. 1 maps to 2, 4 to 7, 5 to 4, and 6 to 9. We've got those points on the Cartesian coordinate system over here. And that's sort of how we show that they're mapping to one another. We could say then that the function, using function notation, is f, 1, 4, 5, and 6, maps to 2, 4, 7, 9, and 10. So this is an important point here. This 10 is in the codomain, but it's not being mapped to. So it is in our codomain. Remember, the codomain is all possible values that the function could map to. Okay, and then so we can say that the function itself is the set of pairs 1, 2, 4, 7, 5, 4, and 6, 9. The range is only the values that are actually outputted. So 2, 7, 4, and 9. 10 is part of the codomain, but it's not actually part of the range. You'll notice that the range is always a subset of or equal to the codomain. So if we ask ourselves now, all right, how do we find the inverse function? Well, if we do some magic up here, the domain and the codomain swap, and we get all this going on. So let's just keep our attention here for now. So it's 2, 7, 4, and 9. They all swap. They're now all parts of our domain. 10 is not part of our domain, and this is the really important point. Even though it was in the codomain, it's not in the inverses domain. And the reason is that the inverse can only accept outputs they can only accept outputs from the original function, and 10 was not an output of the original function. So we end up with an inverse function that has a domain of 2, 7, 4, and 9, but it only maps to 1, 4, 5, and 6. And so we say that the function inverse is 2, 1, the 0.21, the 0.74, the 0.45, and the 0.96. You swap the x and the y values. So you'll notice up here that it's a reflection along this line, y equals x. So 1, 2 becomes 2, 1, 4, 5, 5, 4 rather becomes 4, 5, 4, 7 becomes 7, 4, and 6, 9 becomes 9, 6. Okay, and remember the range is only the values that are actually outputted. So 1, 4, 5, and 6. So just to sort of summarize, the domain and the codomain swap when you find the inverse function, but it's important to remember that the inverse function can only accept values that were outputs of the original function to be included in their domain. So it's a small but important point. For most purposes, all you need to be aware of is that the range of the original function becomes the domain of the inverse function, and that is more than you need to know. So hopefully you found that helpful. Good luck with everything you're doing.